Hello everyone, welcome to my channel. Myself Vignesh Anand. In this video, we are going to see about the induction motors, their construction and their types. Normally, the induction motor is a most commonly used motor, and it runs in a speed of lesser than the synchronous speed, which means the rotation of this magnetic field in the stator is will be uh, having some speed which is lesser than the synchronous speed. It works on the principle of electromagnetic induction. Electromagnetic induction in the sense the phenomenon in which the electromotive force induces across the electrical conductor when it is placed in a rotating magnetic field. So this rotating magnetic field is produced in the stator, and which the conductor is placed, and that conductor further moves in according to the magnetic field. This is one of the main type of your asynchronous motor, which means induction motor is a asynchronous motor. In an induction motor, only the stator winding is fed with a AC supply, which means a single phase or three phase type of AC supply is used for our stator winding, and the alternating flux is produced around the stator winding due to the AC supply. Then this alternating flux will revolves that motor in a synchronous speed. So the revolving flux is your rotating magnetic flux, which means rotating magnetic field. So the relative speed between the stator RMF and your rotor conductor cause the induced EMF in the rotor conductor, and the rotor conductor are short circuited, and hence rotor current is produced, due to which induces an EMF in it. So if the induced EMF in your rotor will produce an alternating flux around it, and further that flux will be having some lag behind the stator flux. So the direction of the induced rotor current is according to the Lenz's law, which means the rotating magnetic field which the stator is produced and this induced EMF which is produced by the rotor will each other opposes each other. So the rotor will try to catch up with the stator RMF. Thus the rotor rotates in the same direction as like a stator flux to minimize this relative velocity. However, the rotor will never exceed in or succeed in your catching the synchronous speed. So if the rotor catches the synchronous speed means, which means the rotor speed and the stator speed is equal, means then there will be no more flux created or no more torque created in it, and thus the rotor will be in a static position. So the in a induction motor, the stator speed will be in a synchronous speed and rotor speed will be in a less than the stator speed. So in this way the induction motor will operates. So the difference between the synchronous speed and the actual speed of the motor is called as a slip. The slip is given by a formula as ns minus n divided by ns into 100. So this is the construction of your induction motor, in which we have various parts as a stator slots, stator winding, and the outer frames are yoke. Then the rotor starts, rotor winding, and the shaft and the shaft bearings and the rotor drums. So this all will be placed inside your frame, which means frame is your outer covering of your motor. This is how the induction motors construction will be. This is your practical example of your induction motor. As I said, there are stator core, stator windings, shaft, bearings, fans, and rotor windings all will be placed inside the frames. Then coming up to the construction, the induction motor has a mainly two parts. One is your stator and second one is your rotor. Stator is your stationary portion, which means it will be in a static position, which creates a RMF, and rotor is your rotating part. and other parts includes as a stator core, stator winding, frames, shaft, bearings, and fan, and rotors parts also been there. Stator, coming up to the stator, it is a hollow cylindrical core comprised of a laminated and layered thin metal sheets. These thin layers of metal sheets are been produced for reducing your eddy current losses. Then outer frame or your yoke. It is the outer body of your motor. It functions mainly to support the stator core and to protect the inner parts of your machine. Then stator core. Stator core is built of a high grade silicon steel stamping. Its main function is to carry the alternating magnetic field which produces the hysteresis and eddy current losses in it. Then coming up to the stator winding. The stator winding is a wound type and have some number of poles. So depending on the speed of the motor, the poles will be get increases and decreases. So if the number of poles is greater means automatically the speed of the motor will be less. If the number of poles is lesser means automatically then your speed of the motor will be higher. So the stator winding, it may be connected in a star or a delta formation. Next we will see one small example of your overall structure of your induction motor. This is your overall structure of your induction motor, in which the outer coverings, which means end belts, uh, will be placed in your both the sides. Then your connection for your stator will be having in the outside, in which the stator windings will be connected with the three phase or single phase supply. Then the motor frame, which is your outer covering, then your stator electromagnet, which means your stator windings. Then the rotor electromagnet. In here, the rotor is subdivided into two types of rotors. One is your slip ring rotor, and second one is your squirrel cage rotors. Then the bearings which supporting the rotor and the end shafts which connected with the load and fans in order to reduce the heat of your rotor will be provided. Next, one more practical example of your induction motor. This is the practical structure of your induction motor. Uh, so, as I said, same all the equipments and the construction parts will be provided as per the types. Just you can have a view on it. Next, coming up to the rotor. The rotor is your rotational or a rotary part of your induction motor. It is also a cylindrical unit mounted on the shaft that carries the mechanical load. So this rotor is subdivided into a squirrel cage motor rotor and slip ring rotors or a wound type of rotor. Next, we will have a small view on a squirrel cage rotor. So it is consisting of a laminated cylindrical core. The circular slots at the outer peripheral are semi-closed. Each slot contain an uninsulated bar conductor of aluminum or copper. At the end of the rotor, the conductor are short circuited by a heavy rings of copper or aluminum. So the main advantage is that it reduces the humming and which means the humming in the sense noise, sound noise, and provide a smooth and noise free operation. It results in a uniform torque, which means the torque will be splitted uniformly in overall, because the squirrel cage construction also will be like a full cylindrical structure. Then the locking tendency of the rotor is reduced as the teeth of the rotor and the stator attracts each other and locked together. It increases the rotor resistance due to the increased length of the rotor conductors. Then there is an absence of pressures, so automatically it reduces the risk of sparking in the rotor. Next is your face wound or a slip ring rotor. It consists of a cylindrical core that is laminated. The outer periphery of the rotor is also a semi-closed slot that carries a three-phase insulated windings. The slip rings are connected to a variable power resistance bank via brushes, which allows the operator to change the speed of the motor by varying the resistance. Then it increases the torque, which means starting torque, and decreases the starting current. It is mainly used for your control of speed in your motor. Next, we will see the practical structure of your squirrel cage and wound or slip ring rotors. So, as I said, it consists of a metal rings, laminated cores, and copper bars in which the windings will be placed, and further the induced EMF will get induced whenever the RMF, which means the rotating magnetic field produced by the stator, automatically it will affect the uh, rotor by a induced EMF, and automatically the induced EMF which opposes the rotating magnetic field, uh, in certain period the rotation of the rotor and stator will be in the same position, which means the same direction, and automatically the motor gets started, and the electrical energy to a mechanical energy conversion will be take place. So the same structure wise, the slip rings and the squirrel cage rotor will be same, but mostly we will use the squirrel cage type of rotors because of their less maintenance activities. Next, we will have a small look on the types of induction motor. So the mainly there are two types. One is your single phase and the second one is your three phase motor. Single phase motor is further subdivided into a split phase induction motor, capacitor start induction motor, capacitor start and capacitor run induction motor, then shaded pole induction motor. This three phase induction motor, in the sense the rotor only subdivided into a squirrel cage induction motor and wounded or slip ring induction motor. So the rotor only different in the three phase induction motors. Hope you understand. I think so. These are all the types of your induction motor, and coming up video we will have the further discussions on the motor, induction motor. Have a nice day. நன்றி. வணக்கம்.